video, I'll be discussing guided tutorial 5.2, the objective questions on alkenes. So let's get started. The first question here, you are required to name the following compound based on the IUPAC system. So firstly, what you have to do is to count the longest carbon chain, right? That has the functional group carbon-carbon double bond. So if you were to start from top here, that will give you 1, 2, 3, 4, 5, 6 carbon in the longest chain. Please remember that a CH3 that is present in a bracket means it's a branch, right? So if I were to start counting from the bottom, this is 2 carbons over here. So this will be 3rd, 4th, 5th, 6th, and 7. So we have got a continuous of 7 carbons, and that should be our parent name. So the parent name with 7 carbon should give us the name of heptene since it's an alkene. So please cross out answer C and D. Now let's see where is the double bond. So the double bond is positioned at position number 3, meaning the first and the second carbon is here, 3rd, 4th, 5th, 6th, 7. So the double bond is at position number 3, which is correct in both option A and B. Now let's look at the branches. So what are the branches we have? We have got CH3, another CH3, and another CH3 there. So it's a trimethyl substituent present. So that is also correct in our option A and B. And next we have to see the numbering on the longest chain where the substituent is present. So it is present at position 3, 4, and 6. Alright, so that's correct. And finally, since it's drawn in the spider format, we have to make sure whether it's going to be a cis isomer or a trans isomer. Since the two CH3s are on the same side, therefore it is going to be a cis isomer. So you name it as cis-346- hep3-ene. So that's our one answer. Right, let's go on to question number 2. So by using the Zaid's rule, identify the most stable alkene. So what did Zaid's rule say? You must recall that Zaid's said that the most stable alkene is the alkene with most number of alkyl groups attached to the carbon at the carbon-carbon double bond. So if you are unable to see through these condensed formulas, I suggest you draw them out. So option A would give us a structure that looks like this. Sorry, let me correct that a bit. Okay, so here we can see that option A has got 2 alkyl groups attached. What about for option B? So option B, it's quite clear that there is only 1 alkyl group attached to the carbon at the carbon-carbon double bond. As for option C, we have got 4. Alright, we have got all 4 hydrogens that will be usually present on a carbon at carbon-carbon double bond replaced with alkyl groups. And finally, for option D, we have got 1 and 2 alkyl groups attached to the carbon at the carbon-carbon double bond. Therefore, the question says which is the most stable alkene according to Zaid's rule? Your answer would be C, since it has got 4 alkyl groups attached to the carbon at the carbon-carbon double bond. Now let's go on to question number 3. So here, dehydration of alcohol is shown, and you are required to predict the major product. So remember, dehydration of an alcohol is the removal of water, which requires you to remove the OH group and a hydrogen atom. So it's clear that we are going to remove the OH group that is present on this carbon, and the hydrogen must be removed from the adjacent carbon. Alright, so we have this adjacent carbon over here and this adjacent carbon over there. Now, it is actually quite difficult to realize at the first stage that in order to produce the major product, there can be a possible rearrangement happening here. Alright, because once we remove the OH, we will actually form a secondary carbocation since the carbon here is a secondary carbon. Alright, so once we form the secondary carbocation, we can actually move it to the left to improve the stability and make it into a tertiary carbocation. So the intermediate would actually look like this. Whereby after 1,2-dimethyl shift, okay, the secondary carbocation becomes a tertiary carbocation. Right. So once it becomes this tertiary carbocation, now we are required to remove the adjacent hydrogen. And as we can see, the adjacent carbon is a primary carbon as well as a tertiary carbon. So obviously we are going to remove the tertiary hydrogen to get the most stable product. And your answer should have a double bond in the middle. Okay, so the best answer here, as you can see, it would be B. All right. Now next. Question 4. Which alkene produces ethanoic acid and butanol when reacted with hot acidified KMnO4 solution? So reaction with hot acidified KMnO4 solution is our oxidation reaction that happens to the carbon-carbon double bond, and I hope you remember that what we will be doing is we will be chopping our carbon-carbon double bond into half. Alright, and at that point we would include an oxygen. Okay, so let's start doing the chopping and see which would produce an ethanoic acid. So a good way to begin this is by knowing that an ethanoic acid has got 2 carbons and butanol would have 4 carbon. Alright, so one side of our alkene should have 2 carbon and the other side should have 4 carbon. So that eliminates option A sebab option A has got 2 carbons on the left and 2 carbons on the right. So that is not going to be our answer. How about the second one over here? That 2 is not our answer because there is actually, sorry, the first one we actually have, oh yeah, correct. So the second one, alright, so what we have got 2 carbons on the left and 3 carbons on the right. Impossible also. Now what about the third one? So the third one, we have got 2 carbons on our left and there is 3 carbons on the right. Okay, still not achieving 4 carbons that we need for butanol. What about the last answer? So we have got 2 carbons on the left and there is 4 carbons on the right. So this is actually a quick trick to predict the answer. So since we have actually matched the number of carbons on left and right, why not we draw and confirm that this is the answer? Okay, so that would be C double bond C, and we have got a H and a CH3 on the left, whereas on the right we have CH3 on one side and the other side is CH2, CH3. So if I were to oxidize this alkene, okay, whereby I chop it right in the middle, yes, at one side I will have ethanoic acid because oxidation would convert my aldehyde straight into carboxylic acid. Whereas on the other side, it is a ketone and ketones cannot be oxidized even if we have strong oxidizing agent. So the answer is definitely D. All right, let's look at question number 5. Now, when propene is oxidized by cold dilute KMnO4 in a basic solution, okay, the product formed is, so these conditions should remind you that what we are doing is the Bayes test. Now the product of Bayes test must be a diol. So this should give you a good indication to search for a compound that has two hydroxide groups adjacent to each other. So A is wrong, B is wrong, C is wrong. Definitely the answer is going to be D. Alright, so this is very quick way of doing it, or you can also confirm back by drawing out your propene. So this is how your propene is going to look like. So once we do the Bayes test on propene, the product should look like this: CH3, C, H on top, and another CH2 and OH at the bottom. And this is the condensed formula for that. Okay, right. Question number 6. Ozonolysis of an alkene produces ethanol and propanol. So what is this alkene? Now let's draw out ethanol. So how does ethanol look like? So ethanol would look like this. Okay, so because we are working backwards to predict our alkene, so it's good if we can draw out our aldehydes and join them back. Okay, so as you can see, we can join where the carbon double bond oxygen is. It's where the carbon-carbon double bond was previously. So I'm going to redraw back the carbon-carbon double bond and maintain the connection of atoms. So sorry, there is a slight mistake here. Let's correct that. Okay, so CH2, CH3 on the right, and as for the left, it would be this. So shall we name this? Look at the longest carbon chain. That would be 1, 2, 3, 4, 5. So 5 meaning we have got a pentene. So this is not our answer. So where is the double bond on pentene? 1, 2. It's at position number 2. So the answer would be 2-pentene. Alright, next. Question 7. How can we differentiate cyclohexane and cyclohexene? So this is basically a question that is asking you to differentiate between a carbon-carbon single bond compound and a carbon which has a minimum of 1 carbon-carbon double bond. Alright, so the best way that we can do is you either do a bromine test or a Bayes test, right? So the bromine test condition and reagent would be option 2, and the Bayes test condition and reagent would be option 3. So the answer here is 2 and 3. Alright. Question number 8. Propene reacts with hydrogen halide according to the following equation. Which of the following statement is correct? So this is actually your hydrohalogenation of alkene. Alright, and this is the type of reaction is actually an electrophilic addition reaction. So we know that from our reading. So let's look at the statement. The intermediate is a carbocation. Yes. The product form follows Markovnikov's rule. Yes, as you can see here, the hydrogen, okay, goes to the carbon with the more number of hydrogen, all right, which is to the right. And the halogen goes to the center. Okay, so it does follow Markovnikov's rule, and yes, the rate of reaction increases in the order whereby Hi is the most reactive towards this reaction and HCl is the least reactive. I've given reasons for this in your lecture notes, so please go and look back. Option 1, 2 and 3 is correct. Right, question number 9. Choose the correct statement about anti-Markovnikov addition to propene. Alright, so platinum can be used to replace peroxides? No. Okay, the reaction does not occur with HCl in the presence of peroxide? Yes. Anti-Markovnikov only occurs when HBr is used together with a peroxide. Example, right? The product is 1-bromopropane when it reacts with HBr in the presence of peroxide. So let's look at propene. It is CH3, CH double bond, CH2. So when I'm using HBr in the presence of peroxide, anti-Markovnikov product would be a product whereby the hydrogen or the electrophile now goes to the carbon with less number of hydrogen, and the halogen goes to the carbon with more number of hydrogen. So the opposite happens. So when that happens, we can see that the product would be CH3, CH2, CH2Br, and this is our 1-bromopropane. So option 2 and 3 is correct here. Right, question 10. Which of the following compounds can show cis-trans isomerism? So when they are asking which of the following can show cis-trans isomerism, you have to go back to your condition in forming cis-trans isomerism. So the first condition is to have restricted rotation. And where does this restricted rotation happen? You must remember it occurs either at a carbon-carbon double bond or a carbon-carbon single bond in a cyclic compound, for example. All right, and condition number 2 is that two different group of atoms must be attached to each carbon on the carbon-carbon double bond. All right, so let's check that. Make sure these two conditions are fulfilled in order for a cis-trans isomerism to occur. So the first option here, yes, we do have restricted rotation present since we have a carbon-carbon double bond. However, one of the carbon over here has got same atoms attached to it. So option 1 is not in our answer list. Okay, let's look at option number 2. So option number 2, do we have restricted rotation? Yes, we do have, since that is a carbon-carbon double bond. And what about the group of atoms attached? So on the first carbon over here, okay, we have got hydrogen and another large group of atom. Okay, so that's two different groups. Similarly, we have two different group of atoms over on the right as well. So option 2 can. Next, the last option here, do we have restricted rotation? Yes, we do have. This is a cyclic compound. Okay, all carbon-carbon single bonds. And this, looking at these two position over here, yes, they do have two different group of atoms attached. Now, please remember this is a skeletal structure, so there are hidden hydrogens present. So write them out and make sure you convince yourself, yes, there is two different group of atoms attached. All right. So answer for 10 would be 2 and 3. Number 11. So the final question is 2-methyl-buta-1,3-diene can be polymerized to make synthetic rubber and the structure is as shown. Which of the following statements is or are correct? All right. So this compound over here is able to decolorize bromine water? Yes, it can, because it has got carbon-carbon double bond which can undergo electrophilic addition and decolorize out the reddish brown of your bromine water. Next, It undergoes electrophilic addition. Yes, that is very special for carbon-carbon double bonds. And can it be oxidized by cold aqueous potassium permanganate solution? Yes, it can undergo Bayes test. All right, it gives a positive result for Bayes test. So the answer for 11 is all 3, 1, 2, and 3. All right, so I hope you get this. And that's all for this video. Thank you.